Welcome back to the class of physics. This is Ramesh. Okay. In this class we are going to discuss about electromagnetic wave equations. How to write the electromagnetic wave equations. What are the important things the wave equation represent. Before we are going to discuss about that, just we want to clarify the source of electromagnetic waves. What is the source of electromagnetic waves? The source of electromagnetic waves is oscillating charges. In Hertz experiment, it is proved. A single charge which is kept at the rest position, it produces electric field around it, which we studied in the chapter of electrostatics. A charge moving with a constant velocity which produces constant value of current. That means a steady current. So a charge which moves with a constant velocity which produces steady current. No problem. Okay. If the charge accelerates, I think you know the meaning of acceleration, rate of change of velocity. So a charge, when it accelerates, it produces electric field, time varying electric field, as well as the time varying electric field produces time varying magnetic field. It regenerates. One field varying, another field will be produced. Simultaneously, the two waves are propagating in a perpendicular direction. The direction of propagation of electromagnetic waves is perpendicular to the direction of propagation of these two waves, electric waves and magnetic waves. So three waves are mutually perpendicular to each other. For example, the electric field is propagating in the y direction, magnetic field is propagating in the z direction, then the direction of propagation of wave is along the x direction. This we studied in the last lecture also, but just I want to tell you something about the source of electromagnetic waves. So just remember, a single charge produces only electric field. A constantly moving charge produces a steady current. Due to the steady current, a magnetic field is produced around the current carrying conductor, but that magnetic field is not time varying. That is important. But an accelerated charge which produces time varying electric field, due to that a time varying magnetic field is simultaneously produced in a perpendicular direction to the electric field. That is the important concept. Okay. These electromagnetic waves need not any material medium to propagate. We know very well about that. Okay. How the propagation of electromagnetic wave is explained? In what basis it can be explained? The propagation of electromagnetic waves can be explained with the help of electromagnetic wave equations. So electromagnetic waves consist of both electric field vector and magnetic field vector combinedly together. These two are propagates when it is once triggered, that means once started, once produced. These electromagnetic waves regenerates and it will propagate through air or vacuum. Okay. Once it is started, the process goes and goes. Once it is started, these propagation of electromagnetic waves need not this propagation of electromagnetic wave does not need source. The source is must for the production of electromagnetic waves, not a propagation of electromagnetic waves. Once the electromagnetic waves is produced with the help of the source, then the electromagnetic waves are propagates in air if the source was removed. That is the beauty. Okay. So due to these electromagnetic radiations, we can use the wireless communications, etc. There are a large number of applications. So what is the source of electromagnetic waves? Oscillating charges. These oscillating charges is otherwise known as accelerating charges. So when the charges are accelerated, electromagnetic waves are produced. So accelerated charge is the source of electromagnetic waves. Okay. Okay, we are now going with the equations, electromagnetic equation. What is electromagnetic equation? The electromagnetic equations which represents two things. One is electric field, another one is magnetic field vector. In this electric field vector, the electromagnetic equation represent some parameters, some quantities which can correlate, which can relate some quantities. For example, wavelength, frequency, maximum value of electric field. So by writing this electromagnetic wave equation, we can gain the knowledge of the position of the wave at a particular instant. So we can study what is the maximum electric field at that instant, what is the displacement at that instant, what is the wavelength of the wave. So it can correlate some parameters. We can correlate some parameters related to electromagnetic waves in a single equation, that is called electromagnetic equation. We can write the electromagnetic equation separately for electric field as well as magnetic field. Okay. First this is, on y-axis I take electric field. Now the electric field vectors are propagating in y direction. Y direction means here. This is for propagation of electric field. This is for propagation of wave. The wave is propagating in x direction. X direction. The electromagnetic wave is propagating. In z direction, magnetic field vector is propagating. Okay, both are not both. These three are mutually perpendicular to each other. We know very well about this. Now here I represent only the electric field vector under the direction of propagation of wave. This is enough to represent the electric field equation. How to write the electric field equation? By chance I want to measure the electric field at a particular instant. For example, in that instant I want to measure the electric field at that instant. I can make use of electric field equation. Okay, at that instant what will be the electric field? Okay, then how can I write at that instant? Means here the electric field is propagating with respect to time. The electric field vector is displaced with respect to time. The displacement is written as x. The direction of propagation is capital X. Here the displacement is small x. And t is the time period. Okay, t is the time period, x is the displacement of the electric field vector. Okay, now I write one equation, that is Ey. Why I am putting Ey means, here the electric field vector propagates in the direction of y. Electric field vector propagates in the direction of y. This is y. So Ey is equal to E naught. This equation can be represented by both sine and cos. Now I can write in terms of cos. E naught cos kx minus omega t plus phi. What are those things? Here E naught is nothing but this is the maximum electric field at a particular instant t. This is the maximum electric field at a particular instant t. What is the maximum peak value of electric field is E naught. Cos of k, where k is the propagation constant, which is said to be propagation constant. In some books it is otherwise known as wave number. Wave number or propagation constant is k. Where x is the displacement, omega, we know about omega is the angular frequency. Frequency is nu, angular frequency is 2 pi nu. And t is the time period. That means we can make use of this equation to find the electric field at a particular instant, because here t plus phi. Phi is the initial phase of the electric field in y direction. That is the meanings behind this expression. Ey is equal to E naught cos kx minus omega t plus phi. Okay, in this expression, what are the things which are variables and what are the things which are constants? There are three things which are variables. First one is, the variable thing is what? K is variable. K is variable. K means what? K is, K is not variable, K is a constant, X is variable. Here I round it X. X is what? X is displacement. So this displacement changes with respect to time. So time, displacement, both are varies. If these two varies, then the electric field vector in y direction also varies. So these three things, Ey, H, T, these three are variables. Then what are the constants here? Here the constants are E naught. E naught is the peak value of the electric field, which is constant. K is the propagation constant, as the name indicates, which is the propagation constant or wave number, which is a constant for a particular wave. And omega is the angular frequency of the electromagnetic wave, angular frequency of the electromagnetic wave for the electric field, for the representation of electric field. Omega is the angular frequency, which is also a constant. So the constants are, these are variables, and the constants E naught, K, omega, these are all constants. So please don't forget, these are all important things. So when the time varies, the displacement varies, then the electric field propagation in y direction also varies. So these are all varies. So we can calculate at any time what is the electric field propagation in y direction. This is for electric field equation. In an electromagnetic wave, electric field is represented by this equation. How the magnetic field is represented? The magnetic field is represented by the equation which is similar to this equation, that is B. Here the magnetic field propagates in which direction? This is propagates in Z axis. So BZ is equal to, here the peak value of the magnetic field is B naught. B is equal to B naught cos of kx minus omega t plus phi. Yes. This is the expression or equation for magnetic field vector in an electromagnetic wave. So B is equal to B naught cos kx minus omega t plus phi. Here B is the magnetic field propagation in Z direction. Magnetic field vector propagation in Z direction. B naught is the peak value of the magnetic field vector. The remaining things are same. K, X, omega t, everything is same. Okay. So with the help of this electromagnetic wave equation, what are the things we are going to find? We are going to find first one. For example, I will take this expression, this equation. We have to find the value of E naught. For example, if the value of E naught is given to 300, then Ey is equal to 300 cos, some value is given. Ey is equal to 300 cos kx. Here k is propagation constant. It will be, for example, 6.28x minus omega t. The value of omega is 24, for example, t plus 5. If the wave equation for an electric field vector is given like this, what are the quantities or what are the parameters we are going to find from this expression, from this equation? First one is, we can compare this equation with this standard equation. So in this, E naught is equal to, first we have to find E naught. E naught equal to how much? Here E naught, in this place E naught is equal to 300. So we can find out E naught. Second one, K. K is given how much? K is equal to 6.28. From this K, we can find out lambda. How? Because the K is nothing but the wave number or propagation constant. K is equal to 2 pi by lambda. So 2 pi by lambda is equal to, substitute this value here, instead of K I write 2 pi by lambda. 2 pi by lambda is equal to 6.28. So I want lambda. So lambda is equal to what? Lambda is equal to 6.28. Sorry, 2 pi by 6.28. What is 2 pi? Value of 2 pi is 3.14 into 2, 6.28. 2 into 3.14 by 6.28, cancel out each other. So that will be equal to 1 meter. So, so by this equation, we also find out the value of lambda. The lambda means wavelength. In this expression, which is lambda? This is what lambda? This is lambda. Lambda is the wavelength of the wave. Here we find wavelength of the wave with the help of this expression. Okay. Then third one is first E naught we find out. Then K. K means wave number of propagation constant. We can find the propagation constant K. In the third step we find lambda. Okay. These three things we find out successfully. Then fourth one is what? The fourth one. Okay. Fourth one is omega. What is the value of omega here? Omega is, fourth one is omega. Omega is the angular frequency which is equal to 24. Because omega t here 24t. So in the place of omega here 24 is given. So omega is 24 here. Okay. Then what is the next thing we are going to find? The next thing we are going to find is one of the important thing, which is nothing but V. V means the fifth one we are going to find is V. V is what? V is nothing but, which is velocity. We can find out the velocity of this electric field wave by help of this equation. How? We have one relation, V is equal to omega by K. How this equation comes here? What is the value of omega? Omega is nothing but, omega is equal to 2 pi nu or 2 pi by t. Okay, 2 pi nu I write here by K. What is the value of propagation constant K? The propagation constant value is 2 pi by lambda. When 2 pi get cancelled, this nu is multiplied by lambda. Nu lambda is nothing but velocity. Frequency into wavelength is known as velocity. So omega by K is equal to V. Okay, so by dividing these two, we get the value of velocity. What is omega here? 24. What is K here? The value of K is 6.28. So 24 by 6.28, what the value is this? Approximately it is 6 by 4. 6 by 4 approximately it is equal to 4. It is approximate value, not an accurate value. It is approximate value. So we can find out the velocity also. So in these electromagnetic wave equations, it can be written into two forms, because this electromagnetic wave is this electromagnetic wave is propagated with the help of the electric field vector and magnetic field vector. Electric field vector and magnetic field vector are propagated to produce electromagnetic waves. That makes the electromagnetic waves. So it has two components. One is electric field vector, another one is magnetic field vector. So electric field vector is represented by this equation. Magnetic field vector is represented by this equation. Both are important. By this equation, we have able to find the peak value of electric field. Second one, the wave number or propagation constant. Third one, lambda, that is wavelength. Fourth one is angular frequency. And the fifth one, the most important thing, is velocity. All these things we are able to find out. So this is about electromagnetic wave equations. These electromagnetic wave equations are very useful by studying about a propagation of the waves. That is most important thing. The last one thing I want to tell you is one. In this electromagnetic equation, here the kx value is positive and the omega t value is negative. That means what? Here the wave is propagating along x direction. Now the wave is propagating in the direction of x. If both the values are positive, that means plus kx plus omega t, then the wave is propagating in the direction of negative x. That means this direction. So I want to tell you once again. If the wave is propagating in the direction of positive x-axis, you have to put plus kx and minus omega t. If the wave is propagating in this direction, that means negative x, both terms are positive, plus kx plus omega t. Okay, this is one of the important things I want to tell you. So these are the things we discussed in this class here. Okay, all the things are very useful. I think, I hope you understand better this electromagnetic waves now. Thank you for your listening. Please make use of it for your exams. In the next lecture, we are going to discuss about the properties of electromagnetic waves. Till that, thank you my dear friends. Thank you my dear students. Bye.